Good day, everyone. So today we shall be looking at the correction of question 4, Roman figure 3 of this year, physics question, paper 4, variance 1, May, June 2023. We've solved all these questions before, but I noticed a small error in this question, Roman figure 3 question, number 4. This is a technical error which I want to call your attention to. So it's going to help you to understand the concept even better. Now this is a question on your screen, and the question is this: doing a change. Okay, before this question, so we need to look at this graph again. We've done it before, but let's look at this graph again. Let's sketch the graph. It said a gas X with pressure 2P and volume of V. So when you see X, under X you see volume V and pressure 2P. Okay, is cooled at constant volume to Y. Is cooled means with a pressure P. Is cooled to pressure P at constant volume, which means this is what is going on. It decreases to P at constant volume V. So the gas is then heated at constant pressure to Z with volume 2V. It heated means that the volume increases at constant pressure up to volume 2V, up to V. So this place here is Y. Let me see, the gas is cooled to Y. Okay, this is Y. And is heated to Z. This point is Z. Finally, the gas returns at constant temperature to state X from Z to X. What do you notice from Z to X? You notice that the pressure is decreasing from Z to X. The pressure is increasing from Z to X. Volume changing from 2V to V, while pressure increases from P to 2P. That should be Boyle's law. So Z to X is Boyle's law. And Boyle's law is pressure is inversely proportional to volume. If you check from Z to X, it obeys this. From Z to X, pressure increases, volume decreases. Of course, if you are familiar to Boyle's law, it's not straight. The line will not be straight. To be a curve from Z to X. A curve from Z to X. You get your full mark with that. I did that in the first video. I'm just trying to repeat it to help us solve this question further. Now this is it. Now let's go to the question. Why we are doing this video again. So doing the change of state from Y to Z. Pay attention, please. The increase in internal energy is U. From Y to Z, you can see increase is U. Doing the change from Z to X, work done is W. Anyway, the question is this: we should fill in this table in terms of P, V, U, W. Let's fill in. Now the first one, X to Y, increase in internal energy. Increase in internal energy from X to Y. Now first, let's go to X to Y. Now from X to Y first, this is what let me label it from X to Y. Let me call it A from X to Y. X to Y, we have constant volume. What is the formula for work done? Work done is pressure times change in volume. From X to Y, since the volume is constant, change in volume is 0. If the volume is 2, 2 minus 2 will be 0. So work done at that point will be 0. So we did it correct in the previous video. Here is 0. If work done is 0, remember that dynamic since I'm still under x to y, since the first law of thermodynamics is U equal to what? Q plus W. At that point, work done is 0. U and Q is the same. Internal energy and heat is the same. Now, this was a mistake. We need to be very careful. Now, I've observed that U and Q is 0. But now let me go down to Z to X. Now, Z to X, I mean this point, is very important. It's the key to this question. Now, under increase in internal energy Z to X means it's just like X back to what? X. So this Z to X, the internal energy, the increase in internal energy here is supposed to be 0. It's a loop from X to X. It's just like going through X, Y, Z back to X. So from Z to X, the increase in internal energy will be 0. At the same time, at that point, like I said, at that point, okay, so at Z to X, let me prove this further. That the internal energy is 0. If you remember the question vividly, let's go back. At Z to X, it said, finally, the gas returned at constant temperature to state X. From Z to S, it returned to Z from Z to X at a constant temperature. Now, let me analyze Z to X here. Let me put it here. Let me call it C. Z to X. Or let me put it there. Let me put it under. Z to X. Let me put it there. Let me call it C. Remember that I want to prove this internal energy at Z to X as 0. What is formula for internal energy anyway? It's calculated using 3/2 kT. I'm very sure you have done it before in your ideal gases. Internal energy is 3/2 kT. Now, change in internal energy is also 3/2 change in temperature. But at constant temperature, Boyle's law is applied or is valid at constant temperature. Why am I saying Boyle's law? Z to X obey Boyle's law. BL. Z to X obey Boyle's law. And Boyle's law, pressure is inversely proportional to volume at constant temperature. So at constant temperature, using this formula, the temperature is constant, change in internal energy will be equal to 0. Now, here is 0. So Z to X, the internal energy, increase the internal energy at Z to X is 0. Since the coulomb of this increase in internal energy is like a loop from X to Y to Z, then Z to X, from X back to what? X. So since it's a loop, it's expected that since it's a loop, so increase in internal energy from X to Y plus increase in internal energy from Y to Z plus increase in internal energy from Z to X must equal to 0. Is a loop. That's the rule for internal energy. I don't know X to Y. Let me call it I want to use a variable. Let me call it K. But Y to Z is U. Z to X is 0. They must equal to 0. Hence, K, U plus 0 is U equal to 0. What is K? K is minus U. So which means the internal energy as X to Y is minus U. This is the mistake I didn't consider earlier. It's minus U. So if it's minus U, remember remember at this point, at x to y, the internal energy and the heat, they are equal because the work done is 0 at x to y. Internal energy and the heat is equal to 0. And x to y, my internal energy is minus W. So if my internal energy is minus W, then Q also be what? Minus W. Since internal energy and Q and the heat are equal. Since my internal energy is minus W, so the heat thermal energy also be what? Minus W. This is key. Please pay attention to it. So let's progress to the next one. We need to fill in the table. Now, the next one. Okay, look at this. The last column, Z to X2. I'm still going back to that. Z to X. Now, the internal energy here is 0. The work done is W. Now, let me go back to the question. What is happening at Z to X? Still Z to X. What is happening from Z to X? Okay, I label it. Is Z to X is down. There's expansion at Z to X. This down part is about Z to X. There's expansion. How? The volume. Is there expansion from Z to X? No, there's no expansion from Z to X. Sorry, the volume decreases from Z to X. It's not expansion. From Z to X, the volume decreases. That's from 2V to V. From 2, the volume decreases. Anyway, I don't think I even need that analysis because we have two variables already at that point. So just use the formula. So since I'm still on Z to X, since Q U equals to Q plus W, the column of Z to X, that column, the U is I think it's 0. I don't know Q, but I know W. But I'm looking for Q. Q will be what? Minus W. So which means in the heat transfer from Z to X here will be minus W. So we are getting there. The heat down is minus W. Now let's go to Y to Z now. Y to Z, yeah, there's expansion. Y to Z, check it. The volume increases. Y to Z, there's expansion. Volume increases from V to 2V. When volume increases, remember, there's less pressure. Anyway, from this diagram, volume increases at a constant pressure. But when volume increases, there's less pressure. As in, the kinetic energy reduces. There's loss in energy. In that case, work is done by the gas, not on the gas. So in that case, work is done. So work is done by the gas, not on the gas. So work done from Y to Z is by the gas, not on the gas. And there's loss of energy. Like I said, the kinetic energy decreases. There's loss of energy. So in that case, from Y to Z, formula for work done is P the V. So since the work is done by the gas and there is loss of energy, so the work done will be minus P the V. So here it will be minus PV because they didn't say in terms of the V. So if the work done is minus PV, since U equal to Q plus W, so I'm looking for my Q. U there is plus U. I don't know Q, and work done is minus PV. So therefore, Q in that case will be U plus PV. So this place will be U plus PV. That is the correction. I want to believe it is clear. So please subscribe to my YouTube channel. There are more interesting content coming. Oh, let's before I go, there was a question I saw earlier. Question 2B. Yeah, this question. This part on how to calculate the spring constant. If you check my previous video, so I got 1.387. If you check my previous video, tension equal to Ke from Hooke's law. There are two tension in this particular question. So it's going to be change in tension equal to K. Extension is always new length minus original length. So our K will be change in tension over new length minus original length. So K will be, change in tension will be 3.19. When mass is attached, it increases. When mass is not attached, naturally, I think you got 2.9. Check the previous video, you see it. All over 10.8, the new length. Original length is what? 8.5. It's to be in centimeter. So let's calculate this. At the end of the day, we're going to have 3.19 minus 2.9. So we have this divided by 2.3 divided by 2.3. Let me check. 3.19 minus 2.9 divided by 2.3. You have 0.13. Okay. 3.19 minus, it should be, if you use 9.81, it should give us 2.8. Let me confirm it. 0.29 times 9.81. Not 2.9, it's 2.8. Be careful with approximated value. 2.8449. At the end of the day, you're going to have 0.15. So the mistake was I did not subtract the tension. I only used one tension. I omitted because I've forgotten that we have two tension. So that's the answer. That's the only part. So thank you. Please subscribe to my YouTube channel. More content are coming. See you soon.